All right. Welcome back. Hope people are doing well on this Wednesday. So we'll begin, I think, with the same sort of things we've been doing or the same pattern we've been working through over the past few weeks. A few administrative announcements first. Just a description of kind of where we're at. Everyone probably kind of knows where we're at, so I don't have to say too much about it. We're sort of at the end of the course. Monday of next week is the last class day for us. As of today, the only assignment that is remaining to be done is the final exam, which will be due, which will take place next week during final exam week. So I guess I would say, some notes about that. Like I talked about, I think last time, my sense is that the final exam will be about 15 questions long. Somewhere between a half to a third will consist of questions coming from chapter 17 through 21 of the text. So the last bit of material that you're responsible for on the final will be the paired t-test, the paired data t-test coming from chapter 21. So that's sort of the end of the line for us. Final exam will take place from the 26th to the 29th. I'll open up the final exam on the morning of Monday, April 26th at 8 a.m. And you'll have until 5 p.m. on Thursday, April 29th to complete it. So everything's kind of done. I'm sort of finishing up grading some items that are in the queue. I should have that finished by Friday or maybe Saturday at the latest, maybe Sunday at the latest. So you'll have an account of where you stand in the course. The weighted total already probably gives you a pretty good idea, because a lot of the assignments that are not yet in will probably not affect the grade one way or the other too much. The weighted total, I weighted it according to how things are described, or the weightings that are described in the syllabus. Couple additional. Yeah, so Charlotte asked if the question, like, is the final exam cumulative? I would say that the final exam is cumulative, but what I would say about the final is it will be 15 questions long, so the length will kind of be similar to what we've done so far, but it's not cumulative in the sense that I don't feel like I don't feel like I need to ask question. I don't feel like I need an even coverage, if that makes sense. There's a portion of the material that we've discussed that you've not been given a test over yet, and this comes from 17 through 21. And because of this fact, if you have a 15 question test, I'm thinking that, somewhere between 5 and 7 of those questions will come from chapters 17 through 21. And then the remainder of the questions will come from everything else, chapters 1 through 16. So the emphasis, I would say, it's cumulative, but the emphasis is on the last few chapters. You haven't had a test over that. So that's the reasoning. Does that answer the question? Okay. Yeah, so with the final, in general, you shouldn't stress out about final exam in the course too much. And the main reason is that if you've kind of been following the conversation, if you've done well on the other two exams, you're comfortable with the homework, there's not really a whole lot I can ask you on the final, which will be shocking in any way. I feel like, when I've taught courses like this in the past, the result on the final tends to correspond to the result on other material. There's some variability, of course, but it's not, very rarely is it the case that, people have a major issue on it if they've been following along in the course. So do what you can, study for it a bit. Again, the final is open book, open note, open StatCrunch, so you can use all of those tools. There's no restriction on that kind of thing. If you feel like you need access to the course materials, that's okay too. Yes, Lily.
Any updates on whether or not those questions will disappear the second we answer them?
Let's talk about it. Do people want a different arrangement than do people want a different arrangement than the arrangement on the first two exams, where you couldn't go back? I guess that's the issue. If people want that, I'm okay with it. I think it's fine to do that, where you can kind of move around a bit. So yeah, that's fine. Wait, are there other questions? Chloe?
Yeah, so I just had a clarification question. So if if that happened on the test, would we still get unlimited time, or would that be conflicted with that as
Yeah,
well?
I'm not going to put a time limit on it. That's a separate issue. So there's no reason to put a time limit if the other two. So I'm not going to impose one on the final.
Okay.
The,
Thank
the, the
you.
no time limit feature will be retained. So I guess that's what we'll plan to do. I'll make a maybe more formal announcement tomorrow about what the parameters look like. And I guess if you have a change of heart, you can make that clear tomorrow. But it's not a to me either way is fine. So what else? I do think the primary. I mean, I would say this: the primary difference between these two alternatives is I think that with the option that people seem to want, you have to sit down and take the final all in one sitting. So there's no time limit that necessarily has to be attached to that, but you can't close out the test and come back to it, I think. So like the thing has to be open, indefinitely or something like that. So I'll be more clear, I think, about it tomorrow. But you'll have no time limit. And I think what people mostly do, and I don't know how frequent. I mean, you can tell me, but I don't think it's that common for people to work on the exam in multiple separate sessions where, well, I'll do a few problems on Monday, a couple more on Tuesday. I think what probably most people do is they just sit down and take it over some length of time anyway. So I think that's what that other option entails, where you actually just sit down and complete the thing over some interval of time, which is, ultimately up to you. Um, but if people are comfortable with that, I'm comfortable with it as well. I don't have a religion either way about it. Any questions about it? Is that all right? Okay. I think tomorrow and Monday, I kind of intend to. I don't really want to. I mean, so over the past few days, I guess last Thursday, Monday, and a little bit today, we're talking about material from the book that you will not be tested over, just to kind of give you an idea of what's in there. I don't really intend I don't really intend these discussions to be kind of any kind of complete treatment of the material. The expectation is that, if you need to use some of this stuff and in some future course, whoever's teaching that course will go through it more carefully than I am. I'm just trying to put an idea out there about the stuff that we didn't talk about, which might show up in some other course, where the expectation is that someone will actually discuss it carefully before using it, mainly just so that you kind of know it's there. So this is material, I think, in chapters 22 through 25. So it's almost all the way to the end of the book itself. So the material from today starts at around page 800 of the book. That's, I'm not really expecting that people, unless they have a huge amount of free time this week, are reading through chapters 22 through 25. It's just sort of a way of summing things up, and we have the time, so we're talking about it. But I think tomorrow and Monday of next week, I'm not really going to do anything like that. So I think tomorrow and Monday we'll probably just sit around, talk about which will actually be tested over for the final. We'll have those days be review days, if that makes sense. In general, when you talk about 14-week courses, I've honestly never been entirely sure how to handle reviews. Um, in the past, when we were in classrooms, I tended to show up sometimes and just ask people if they had any questions about the material. Sometimes you get pretty clear questions, but I think mostly what people want. But over time, you realize what people mostly want is kind of an account of what you might expect on the final. And to be honest, I'm okay with that. So I think on Thursday and on Monday, what I'll probably do is just discuss maybe in more concrete terms, what you might expect, since the final isn't supposed to be taking place in class. So you're sort of on your own to do it over a 3 or 4 day period. It's less of an issue where you have to have some sort of instant recall of information. So maybe that's good. But I guess people might want to know, what what you might actually what sort of questions might be appropriate to look at when you're thinking about a potential final exam. And I'm okay with kind of providing that, giving you an idea about what what I think is important, what I intend to put on there. I'm not going to give you a blueprint for the final. I mean, anything that we talk about over the next couple of days is not going to appear on the final, in the literal sense. It won't reappear. But, just some idea of what to expect. So you can also come with questions tomorrow and Monday about whatever you like. But, we can talk about things maybe more concretely tomorrow and Monday, if that's okay. If people want to look at particular questions, they want to ask particular questions, I'm open to that as well. I also feel like, there was this issue about there was one technical issue, I think, with my stat lab where people were talking about how do you actually access, the results page for the course, where you can go back and look at the homework. I feel like I should probably go through that tomorrow as well, just so you can kind of go back and look at the assignments. One word of warning about it. Is it practical to go through every single problem on all homework assignments that we've done? Probably not. So, the sense I have is that when people probably want to look at one or two things, but you might want to know what that option looks like, so you can kind of go back and look at problems, just to familiarize yourself with what we were talking about several weeks ago, rather than just last week. So I feel like I should do that as well. And that's kind of where things sit. I feel like things in the course have gone fairly well. People seem to have adapted to the Zoom environment in a way that's pretty positive. We've certainly covered the material. So overall, I think you should be pretty happy with all that you've done over the course of the semester. So yeah, good work. Beyond that, I don't have too much more to say. One more thing I want to talk about today. So right now it's about 108. I'd like to give one more account of kind of where we are in the course, and then talk a little bit about how or what we've been talking about over the past few classes that is optional, how that fits within the framework of the course. So I'll have to write a few things down, and I want to give kind of a bird's eye view of ANOVA. So we'll sort of describe what the acronym means in a little bit. So, in the sense, the course so far, in some abstract sense, or at least the last few weeks of the course, looks a bit like this. So, we're at the point of the course when we're thinking about inference. So the stuff prior to that I think is important. These are discussions of probability models and how you develop the idea of a random, like how you come up with a random sample, what's an experiment, what's random, and the role that randomization plays. So I guess I would say, this is not a linear development of the course. It may not look on the schedule like we've done this, but, in a sense, thinking about randomization and the role that it plays in both surveys and experiments is important, together with probability models. So probability models for us are the mathematical models which govern how we feel about the sample data, I guess. And, in the third major sort of thing, the thing that we're talking about, I think more recently, inference. So we have, this is I'm sort of covering a lot of ground with these words, but we have a probability model, which, in some sense derives from, a null hypothesis, or maybe even we just want to estimate something, if we're talking about interval estimates. We want to estimate something and think about where that estimate is. How compatible is the data with the model? And there are all sorts of details, and I'm sort of sweeping under the rug on that one page. People are sort of want to ask about this, but there's always this question about whether or not you think the model is appropriate, whether or not some sort of set of conditions is satisfied. You know, the conditions that you're talking about tend to govern the shape of the probability model that we're going to be using, even without the idea of the null hypothesis. So these are important to check, but that's kind of how the course looks. It's those three things. You know, you're sort of setting up, you know, you're setting up and thinking about the role that randomization plays when you're sort of designing an experiment, when you're trying to survey something. Then the next thing, you know, of significance is we talked a little about probability models that we wind up using. And for us, this mainly is the normal model and the binomial model. And it's kind of where a lot of the theory of what we're talking about over the past few weeks comes from. And then lately, you know, it's a discussion of the compatibility of the data with the probability model under the null hypothesis. So, you know, in a way, this is kind of where, you know, this is kind of what we did in the course. If you look at the entire schedule, you know, it's you know, have sort of a blow-by-blow account of what this amounted to, but this is basically it. And what most people find is this last bit with inference is a little confusing, and it's understandable. So if you're trying to think about what we did over the last few weeks, I think it looks a little bit like this right here. We were thinking about inferring some things about population parameters in two different situations. Broadly, we were thinking about what to do with population proportion, maybe even more than one, and population means, maybe even more than one. So for proportions, you know, the problems that we would consider would tend to break down into one of a couple of categories. There's one additional category that we talked about only on Monday, which I'll put over here because I think it belongs in this category. But we would normally deal with one sample or two sample. So if estimation's your thing, you know, with one sample, you're thinking about P. With two sample, you're thinking about P1 minus P2. There's one more thing. So it's a nice red line. And that we talked about on Monday. And so you probably want to view something like the chi-square test for the goodness of fit, chi-square test for homogeneity and for independence as belonging over here. It's related to counts. That's kind of where proportions lie. So I'll write this. I notice I put it in red because it won't be on the final. And so, you know, up to this point, this is kind of an account. For chi-square test, you're sort of discussing, you know, how do the distributions of counts, you know, how does that look? You know, so here, you know, with proportion or even difference of proportion, the conversation is much more restricted. You're either looking at, in some sense, the count in one category you're comparing to. Here, you're looking at a distribution. And so you may think of that as being kind of a generalization of something that looks like two-sample test. With means, it's kind of the same story. You know, we might deal with one sample. So let me move this over here so I can write a little bit more freely. And so when you're thinking about one sample mean, you're usually trying to talk about inferences from you. We also discussed this concept of two sample. And for means, we found ourselves in two different situations. You know, we were dealing with independent groups, and for this, you know, I forget the numbering of the written assignment, but there was a written assignment in which this came up when you were dealing with some difference of heights between football and basketball players. I think that was written assignment 7. If you want to go back and look at that, or if you're dealing with two sample, but you have paired data. And this type of problem, the basic exemplar would probably be found in written assignment 21, though of course there are others. And you know, the generalization of this we'll see today, and that's kind of what one way ANOVA is. I don't want to get into the weeds of it. I'll talk a little about, you know, an example of this in just a second. I'll at least show you how you use StatCrunch to get a result and how you interpret the results. I don't want to get into formulas. I'll talk a little about the author's treatment in chapter 25 it is. And of course, with this picture, we also have this idea of regression And that was the topic on Monday, how you talk about the regression model. It doesn't fit obviously into either of these categories, but if you had to put it somewhere, it'd probably be over here somewhere. One way of viewing what we did, or viewing regression, is it's a discussion of, like, in some sense, means which move in some sense. And, you know, in chapter 23, the author wants to make that kind of, or chapter 23 and 24, the author kind of wants to make that precise. You know, for regression, it turns out that inference for regression coefficients looks an awful lot like inference for means. And that's not an accident. They kind of belong to the same kind of general category of things. So, you know, linear models, basically. So when you're thinking about the sort of work we've done, you know, this is kind of where we're at. I'd like to spend a few minutes talking about ANOVA through a problem. You know, and, you know, if you stare at this long enough, at least in some purely abstract sense, you also get a sense of what I might even ask on a final exam. Because, you know, I guess in these cases, you know, to be kind of explicit about it, you know, at the end of a course, you know, where these methods are discussed, I feel like I have to ask about all of these things where you're sort of looking at, you know, one sample, two sample, one sample mean, independent groups, paired data, maybe how they're distinguished. I guess so that's probably right there, like 1, 2, 3, 4, like five questions, you know. So when you're talking about a third of the 15 questions, you know, that's 5 of them right there. So 5 out of 15 is a third, I guess. Maybe I can imagine asking another question or two, you know, from this diagram, but that's kind of where we're at. So before I move on, do people have any questions about what I'm trying to say? Like, when you look at that diagram, I think what I'm hoping that you see is sort of an abstract version of how the final exam ought to look, or at least or how a third of it would look. This is kind of what we've done recently. So that diagram kind of represents chapter 17 through the current discussion. So anything so far you'd like to ask? So when you're looking at that diagram, the thing to think about when you're preparing for the final, when you're thinking about what might be on the final, is, do you kind of have a do you have a sense of how questions from each of those 5 categories might look like? What might someone ask that, you know, from a practical point of view, what might someone ask, you know, sort of belongs to those categories? We can talk a little more about that, I think, tomorrow and on Monday of next week. But to be honest, you might already have your own ideas about what might fall into those categories. And you probably have a pretty good idea if you go back and look at some of the homework that was recently done. These are the kind of things that someone might ask. So the last thing I think I want to talk about in the course is the generalization of this independent group means difference. And so the only reason I bring it up is because, you know, I feel like, you know, in some classes it actually does appear when you're looking at group differences through the lens of comparing their means. What I'm about to do is not really meant to be a comprehensive discussion at all. When you build the idea of trying to do ANOVA into a class, you usually take at least a week to talk about it. And so, you know, I don't really intend that people should take a look at what we're doing right now and like have some sort of complete idea of what it is. I just want to give people some idea of what it is, just an example, so you can kind of see where it might come up. So One Way ANOVA, and ANOVA, the acronym stands for Analysis of Variance. It's a way to study population means across more than 2 independent groups. And so if you look at what we were doing with comparing 2 groups, we were you know, the approach is kind of limited because we were limited to looking at differences like mu1 minus mu2. But if you have 3 groups, this doesn't really make any sense anymore. Like, how many differences can you take if you've got like 4 or 5 groups? What you want to be able to do is sort of to look at multiple means and kind of compare them all at the same time. And One Way ANOVA basically is giving you a method to do that. what does that method look like? Now, what I would say, it's in chapter 25, and you can kind of read through, in particular, 25.1 and some of the succeeding sections. I mean, one thing that I would say about it is I like the textbook quite a lot, but I think that in chapter 25, the description of One Way ANOVA, it's one of those things where I think, the author probably could have written down more formulas. I don't usually think that about most books, but in this particular example, you kind of need them. There are a couple of things in 25.1 where the author just sort of writes something down, and it's very difficult to see, where it comes from. Some of the sentences, some of the writing is doing a very heavy lift, and it's, not entirely clear what, what it is, that, what it is, why you're supposed to think something's true. The reasoning is sort of opaque sometimes. There are other treatments of One Way ANOVA, which I think are a little more clear, but unfortunately those take way too long to discuss. So when you're thinking about differences of means, I guess, if you're in this world, we have a null hypothesis, which is essentially that the means agree. Now, you might remember that when we were thinking about this problem from a practical point of view, we generally establish the null as being the difference of means is 0. It turns out for what we will want to do, a more helpful formulation is an equality of means, which looks like this. So for One Way ANOVA, it's an extension of that idea. The null hypothesis is that you have many different potential groups, but you're assuming that their means all agree. So I'll show an example of this in just a second. And the alternative, you can mathematically, well, I guess I should write down, dot, 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 you can have many means in different groups. The alternative is that at least one mean is not equal to the others. And, to say something like a big chain of equations is not true, we're looking at an alternative, it doesn't mean that they all have to disagree. It just means that, at least one of them disagrees with some other common number. Could mean that they're all different, but at least one is. So this is the null and alternative hypothesis when you're dealing with One Way ANOVA. And, so how does it actually look from a practical point of view? What is it that you're actually looking at? What's the test statistic? So for One Way ANOVA, in some rough sense, roughly you compare what I want to call variability between the groups with variability within groups. Now, as it turns out, though, I would say that without a precise formula, it's very difficult to see this. As it turns out, under the null, the two quantities that we're talking about, the between groups and within groups, want to measure or want to estimate the same thing. So when, under the null they do. So the author wants to sort of describe what this is. If I were reading 25.1 without thinking about the formulas at all, about what the author is saying, I would have a hard time following the discussion, but that's the idea. The idea is that you have got one and another thing, and they both want to estimate the same thing. So it turns out that what you look at in a case like this is you look at a ratio you look at the variability between groups divided by the variability within groups. And if, or I guess I should say under under the null hypothesis, there's some sampling variability, but under the null, we kind of expect this ratio to be about equal to 1. Why about equal to 1? Because if the numerator and denominator want to measure the same thing, but the formulas are slightly different, you may not get exactly 1. But if they're estimating the same thing, you're thinking that you kind of expect the ratio of things which are estimating the same thing to be about equal to 1. And so when you get data which produces a ratio which is a lot bigger than 1, then you wind up with an extreme result. And like with a lot of things that we do, p-values can be calculated and so forth. One additional note, the ratio I'm talking about is the one that you see right here. The sampling distribution is not one that you've actually ever seen before. Sampling distribution of the ratio has an F distribution with some degrees of freedom, which somehow has to do with the numerator and denominator kind of combined. F distribution is this weird skewed right distribution, so you haven't seen it before. It's a distribution which is very heavily skewed right, so it's got one tail. If the null hypothesis is true, you kind of expect to be, you're not surprised by ratios which are approximately 1. Under the null, you're not surprised by those, but you are surprised by extreme ratios, like stuff that's on the order of 6 or 7. So let's see an example of how this might look. There's an example I have right here. So let me, I did have it, so I don't think I have it now. So the example that I'm going to use has to do with hand washing, an actual experiment that's done. It's in chapter 25. It's right down here. So with hand washing, what you see are, you see basically bacterial count here. So the way that this experiment was done is that you have an experimenter that is using basically 4 different methods of washing hands, using 4 different agents. One of those agents is water. Another one is soap, and you have antibacterial soap, and you have alcohol spray, and you have kind of this repeating pattern where these different agents are being used to wash the researcher's hands. Researcher takes hand, puts it down on something like a petri dish, and looks at bacteria count after some amount of time. So develops a bacteria culture, looks how much bacteria is there. And so in this case, you have 4 different factors, 4 different groups, and you're trying to look at comparing the average or the mean bacteria count across the 4 groups. And so when you're thinking about this, one way that you might begin to analyze the data is you might just look at a box plot and think about how it looks. What does the visualization of the data actually appear to you to look like? When you look at a graph, you come up with a box plot. So that's right here. The way that you would get StatCrunch to develop the box plot, the column is the count, that's the quantitative variable. You need to be able to see how the groups vary. So in effect, you want 4 independent box groups. So you group by method, by category. And so when you hit compute, you get a picture that looks a bit like this, right? And so with the box plot, if I make it a little larger, the results aren't probably terribly surprising, particularly in the era of COVID. A year ago, a few months ago, people thought that there was a significant chance of transmitting COVID through contact. I don't think that they really think that anymore, but at the time, it was important, it was very important that people would wash their hands regularly. People were afraid if you touched a doorknob or anything outside, the very narrow confines of your home, you might get the virus. Turned out that, probably didn't communicate that way, but people are probably aware of graphs that look like this, where if you have an alcohol spray, these things are thought to be, at least if you look at this picture, they're thought to be much more dangerous to bacteria versus, gradually you look at just water where, almost no, no effect. I guess it's better than nothing, right? That would have been an interesting fifth group. Don't wash your hands at all. So when you're talking about soap, you've got this weird outlier up here, who knows why that's happened. But with the different groups, you can kind of tell that there's some variability. What I would say about this is if you look at these box plots and you ask yourself the question, this includes the median. So let me make this slightly better. I'll include the mean because that's sort of that's sort of the parameter that we want to discuss. The mean is appearing as kind of a green line across the box plot. If like you would with ANOVA, if your position here is that if the null hypothesis is that all means are equal across the groups, I would say that this set of box plots represents evidence against that null hypothesis. I mean, the point estimates are so radically different. Now, ANOVA will do a bit more than that. It kind of wants to quantify that observation. But if someone were to say, "Hey, man, there's no difference," if you point them at this box plot, you would think that there is a difference, right? If you look at it, it looks like alcohol spray tends to kill bacteria to a much greater extent than water or any of the others. You would kind of wonder about the difference between soap and water and just water. Those aren't that different. But antibacterial soap, like the name suggests, probably kills stuff more than the other two. But if you compare antibacterial soap to soap, maybe it doesn't kill that much more. So, before I go on, are people with me in the discussion? We're trying to look at the differences of all of the means. So the null hypothesis is that the means are all equal. If the means are all equal, and we indeed are taking a random sample of 8 per group, I would say that box plots that look like that are pretty improbable. It looks like we should not expect to see that. This is not ANOVA. We're not quantifying anything, but we at least feel like we know where the answer lies. So do people see what I'm saying here? We're not looking at just 2 groups, which was the content, I think, of a couple of weeks ago. We're looking at 4. Now, when you do one-way ANOVA, there are usually formulas, but no one really ever uses them. The author also does not really mention them. But this is how you get StatCrunch to do it, and you get an ANOVA table, which I'll discuss in just a second. You go to Stat, ANOVA. As you can see, there's like one-way, two-way, and repeated measures. The rest of that stuff is the content of the rest of chapter 25. We're just talking about one-way ANOVA. Now, when I'm doing this, if I just hit the column bacteria counts, I can't really do it. It doesn't really make any sense to set the problem up this way. What I have to do to get StatCrunch to perform one-way ANOVA across groups, to get an actual value for the ratio that I had mentioned early on, you are using the column bacterial counts, but you've got factors which are factors in this case represent the different groups from which the sample of 8 is chosen. I don't really necessarily need very much here. I want to get an ANOVA table and think about it. So the analysis of variance table, ANOVA table always looks a bit like this. What you're looking for here is this number right there. So the value of the F statistic is the value of that ratio. So you're going to get different numbers if you actually are developing random samples. But in this case, in this example, we get 7, and we get an associated p-value of about 0.0011. Now, the way to interpret that part of the table is that if the null hypothesis is true, then the probability of data at least as extreme as this data that we see right here is on the order of about 0.0011. That's a pretty low number. What should you do on the basis of the ANOVA table? What I would say in this case is that when you're thinking about the ANOVA table, when you think about the value of the f-stat together with the p-value, in this example, you would be inclined to reject the null hypothesis that all the means are equal. That's not that surprising on the basis of the box plot. When you look at the box plot, you don't expect to see the box plot that we see if it were true that the means all agreed. This is merely quantifying that type of intuition. So when you think about one-way ANOVA, it's usually much more useful to think about one-way ANOVA in the context of calls, which are a little closer than this one. You kind of already know what type of answer you're going to wind up getting. There's sort of the response statistics by factor. You can kind of see how the individual groups look. What the standard error of the individual. These are about the same, and the standard deviations vary a bit. From a low value of about 26 to a high of about 46. There's some conditions on ANOVA which generally involve, convincing yourself that equal variances of groups are reasonable. I'm not so sure that that's exactly the case here, but when you look at the variability of each within group, maybe they're not different enough to be that alarming. So at the end of the conversation, I think, though, when you get an ANOVA table, what you're looking at is whether or not you have evidence against the belief that all the means are the same. And what this ANOVA table is saying is that indeed you do. And so you just want to think about ANOVA, or what we're talking about at this point, as a generalization of this idea of two-sample mean test, because that's what it is. But cleverly, you're not looking at mean minus mean. You're looking at some ratio of estimates of the variance to get the result that you want. The discussion in chapter 25, if you go back and read through it, it's a bit difficult to follow. At some point, you'd prefer it if the formulas just were written down, kind of follow them. But that's at least what ANOVA actually is in like 20 minutes. If we were trying to do a much more serious job about it, we'd probably spend another week doing it. But we're not going to do that. So that's really the last thing I want to say today. It's about 1:40. I guess right now, we have a few minutes left. I have really nothing new to add. I don't want to start new material or try to do anything terribly ambitious at this point. I want to be able to maybe talk about, we can review a bit, in the remaining 15 minutes if you want. I think what I'll do is, it's about 1:40. I'll be around for the next 15 minutes, I think, in this space if you want to ask questions of any kind that you want. If you don't, then it's fine to leave, and I think go enjoy your day. Yeah. So Angelo asked about the class recording.